I'm Robert, a voluntary fact checker helping you if you're scared. And this is about this story. I'm getting so many PMs about it. I went to look at the CNN tweet, and there were a load of people answering to it scared and afraid that the Earth was doomed by this planet, by this asteroid. I answered a few of them saying no, it isn't. And then the people in our Facebook group, and quite a lot of panic there as well, and all our debunkers answering them over again, saying no, this is not a risk. And it was actually removed from the risk list on February 2nd, 2022. And the word panic killer is made up. I've called it a made-up media name. It turned out it was originally hyperbole from an astronomer or a scientist who said we refer to these as panic killers, but that's hyperbole. It is not even remotely. We were hit by one this big 700,000 years ago. It obviously didn't kill Earth. So it was just a media interview talking to someone and a conversation, and he called it a panic killer, like you might say I've eaten a horse. It's that sort of hyperbole. Another astronomer wouldn't take that literally, but the media did. And there's so the one that was hit Earth 700,000 years ago. Then this we actually see. I scroll down, you can see it's not a panic killer. It was about the same size. If I go down here, I've got there are the. Give me just a second. Excuse me. And this shows this June field, and so these are the. It was Homo erectus, which looks quite human-like, but it wasn't human. And they found that long before Neanderthals, Homo erectus saw it, and they had they see there. These are the tektites. So if you go and look at the effects of something like this, they don't normally look at how far the tektites go, which is a little bit further. But an asteroid this big, if it was to hit New York City, then it would, and this one isn't going to, there's no risk at all, and extremely unlikely, 1 in 100 chance, even if an asteroid this big hit Earth, it was to hit an urban area, and we're not and the expected wait time is hundreds of thousands of years for the next one of this size, and then so you're talking about tens of millions of years before one of this size would hit an urban area. Based on one, well, I mean a little bit, no, it'd be less than that, it'd be thousands of years, it'd be millions of years, because this is quite a large area. So if you talk about the blast wave hitting an urban area, then but anyway, hundreds of thousands, certainly millions of years before a blast wave would hit an urban area. So, but if this did happen, then the blast wave would get as far as Lake Erie and Lake Ontario. This would mean it would blow out it would break windows, shatter windows out to here from New York. So that's a big thing. We don't want it to hit Earth, definitely. If we knew in advance, we'd have to have a huge area to evacuate. If we couldn't deflect it, we'd have to evacuate people from this whole area for sure, and then over this area they'd be warned to keep away from glass windows because they might shatter. So I mean that's a very significant thing. If it hit the middle of the Atlantic at this size, then the tsunami would be 10 meters high at this distance. I've done all this for 1.3 kilometers. I don't know this size. It could be between 1 and over 2 at its largest size. Gives me a minute. So this is definitely it's a significant size. You don't want it to hit Earth, but it's no way that it's a panic killer. So that's extreme hyperbole. And then then you have the tektites go a little bit further. That doesn't mean that those areas are covered in tektites. It means the areas where you find some tektites. And these are these these things like that kind of fall out of the sky like mini meteorites, and these are the stone axes that are found amongst them. So, I've got a 210 GD. I've got a mistake down there. Just have a little look. What's that all about? Oh, maybe that's just another debunk I've got. Don't know why I've got a link to that there. I'll remove that. That's just a mistake. I don't know why I got that link in there. Anyway, back to this. So, so it was removed from the risk list. It's not a planet killer by any stretch of the imagination. And as I say, I think it, in a way, I hadn't realised when I made this graphic that it was actually came from an astronomer, a scientist. But the way that they've publicised it, and they put planet killer into the headlines, and they never checked. I tried to find I couldn't find an article now or any time saying that it was actually removed, but it's easy to check. So you go to the removed list, and this is the Century Earth Impact Monitoring. This is a big organisation in the United States that was set up by Congress some decade or two ago to specifically to look. I think it was maybe in last century. I'd have to double check. Specifically to look for asteroids. And so this is the gold standard. It's widely recognised, highly reputable. Their orbits are extremely accurate. They know exactly what they're doing. They know all the subtleties of orbits and what can affect them. That's their professional work. That there are many people who their life's work is to do that. And they removed it from the risk list on the 2nd of February. It was covered on the 13th of January. And then they found pre-discovery images, which is quite common. They found just a speck of light, which at the time they thought was a star, and they didn't notice that. So people tend to think it's just a faint star that hasn't been observed before, and they don't. There's so many faint stars, and if they're not actually trying to enumerate all the stars in their survey, and they found this one from in a previous image from 2017, and given 5 years of orbit, then they could get a very exact, accurate orbit from that, and then they removed it from the list. That's very common. And so then the surprising thing was that having discovered it, then how did we manage to miss it? It's a little bit surprising that we haven't discovered it before. And the reason is it's on a it's a very inclined orbit, very steep orbit. This is Earth's plane, and these lines show, they drop those lines down to the plane of Earth's orbit. So from that you can see how high it is above Earth's orbit. And its distance is, remember the distance to the Sun is 93 million kilometers, so that is a very long distance. The closest it gets to Earth's orbit is 7 million kilometers. And if you don't have an idea of how much a million is, and most people don't, then if you were to travel non-stop for 326 days, nearly a year, in a 747, fueled as it flies, 24 hours a day, on and on and on, for 326 days, that's how far you would travel. And you would circle Earth 176 times in the process. So that is how far you would have to go to get to the closest is get to Earth's orbit, not to Earth, to Earth's orbit. So it gets very far away from us. So you can see why they were able to remove it from the risk list, because it's not close enough for Earth to change its orbit significantly with each of its orbits around the Sun. So it's in quite a stable orbit for thousands of years into the future, like maybe hundreds of thousands of years, certainly for thousands of years. So there's no risk to Earth, none at all. And then over those very long timescales, we can definitely deflect it. We can deflect something like this. We know how to deflect it already, but we don't need to. Over maybe 20 years or something to deflect it. It was headed for Earth, and especially if it's got a flyby of Earth beforehand, then it becomes much easier to deflect. So how did we miss it? There are two possibilities. Partly its steep orbit helped because we tend to focus naturally enough on ones in the equivalent of Earth. We have a telescope like Atlas, which look very frequently at the sky every 3 days, but they are optimized to look for along orbits that could hit Earth. And so this one that couldn't hit Earth and is very far away, and it would be quite easily missed by ones that are trying to find ones that could hit Earth. So missed because of its steep orbit. Another possibility, even so, it's quite surprising, because if you look at its orbit, it goes out nearly to Jupiter's orbit. Remember, this falls down to the nearest part of Earth's orbit. This is Jupiter, so it's close in the same plane as Earth's orbit, and so it's just inside of Jupiter's orbit. You can see from that where it drops down to. So it would be called a Jupiter family comet, I think. And so an asteroid this large and would have been spotted. So unless Earth was synchronized with it, because sometimes Earth will be on the same side as it. So your Earth would be there when it's just there, and it'd be quite hard to miss it. Or if Earth was there when it was just there, or there when it was just there, or whatever. If it's there when it was there, it'd be quite hard to spot. So there's some kind of synchronization of the orbits, so it's always way out here when Earth it's on the night side of Earth. That's the sunny side of Earth. This is the night side of Earth. Then if it's close when it's on the night side of Earth, if Earth was there when it was there, we'll spot it easily. So it's a bit surprising that we managed to miss it for the 10, 20 years or whatever that we've been searching for objects like this. So that's one possibility. But another possibility is it's actually a comet. So they don't really know much about it at this point. It's just a point of light. And if it's bright, then it means it's smaller. But it could be a comet that, or partially, a comet that is turning into an asteroid. Because we get these things that are between the two. They're comets that lose a lot of their ice and they've got a little bit of dirt and stuff behind. So turning into something more asteroid-like. Still with some ice mixed in. And so this could be a comet that's lost a lot of its volatiles, and it brightened up as it got closer to Earth, and it brightened up because it was giving off jets. So it might be that what we see is actually a rather smaller object that has got brighter because it was close to Earth. That could be why we missed it, in which case it's likely smaller than they estimated it to be. So it could be a comet or somewhat cometary asteroid, something in between the two. And we've got very little time. We've discovered, astronomers believe, we've got so many telescopes looking for this. We've got the Vera Lynn telescope coming in next year, 2023, and that will find a huge number of asteroids within a week, because it can look 4 times further than any other telescope of the survey-type telescopes. Something like Hubble or James Webb can look much further than these telescopes, but it looks such a tiny spot of the sky, it's absolutely useless for asteroid surveys, because it would just take it hundreds of thousands of years, or probably, to be able to cover the entire sky to just once. It would take, I don't know how long, a space telescope, but a very, very long time at its maximum magnification to cover the sky map once. So although they're very sensitive, they are no use for this sort of thing. But this Vera Rubin telescope, Vera Rubin, I said that Vera Lynn, didn't I? Vera Rubin, then this telescope is a very big telescope that is very sensitive and does very quick photographs, and sometime in 2023 it's going to be able to survey the entire sky as seen from its location 4 times further away, which means 64 times the search volume. So it's going to find lots and lots of asteroids very quickly. So it will find quite a few of these. It would have found, so with our other telescopes here, if it was double the distance from the sun, 4 times fainter. It was double the distance from the sun from the ones that our other telescopes can see, and the Vera Rubin would be able to see it. So that means that from Earth, I mean, double the distance from the sun, or if it was double distance from Earth, and then if you've got both of those then combined. So if it was double distance from Earth, then it's 4 times fainter. So if our telescopes see it, then Vera Rubin will be able to see it there. So, whatever, if ours can see it here, Vera Rubin will see it there. How far away they can see it would depend on how big it is and how faint it is further away from the sun. But so we can find there are probably very few of these, only a handful of these in very strange orbits that we may have missed so far. Of the 857 we have so far, only one is still in the risk list. 856 were removed, of this size, were removed from the risk list. So you can see that if you discover a new one, it's almost certain to be removed from the risk list usually within a week or two. And sometimes they stay there for a year or two if they're particularly difficult to spot. But this one was removed within a week or two. That's not too surprising. That's normal for this sort of thing. And so this object, the 857 of those, 856 were removed. One remains, and it is expected to miss in 2880, more than 7 centuries from now. And most likely that also is removed. It's just that it needs more observations in order to get its orbit, know its orbit well enough to remove it. So that's the situation. So you can see from that the very few left, and then if we had discovered none of them so far, then it would be expected wait time of hundreds of thousands of years to the next one, to possibly millions of years. But now we've found nearly all of them, so expect wait time much longer than that for the few that are left. Indeed, it's pretty much certain that the few that are left are probably all going to be removed. The chances are 100 that they're not going to be removed pretty quickly, and then near certainty that they can't hit us for centuries, and then that they're going to be removed eventually, like 1950 DA almost certainly will be. So you can see from that how risk from objects this high is this big is very, very, very low as a result of nearly completing this survey already. And by 2025, so we've got Vera Rubin coming next year, and that's going to find a lot of these. And then in 2025, we've got the Space Telescope NEOCAM, which is an infrared telescope, and it's going to orbit in the position of gravitational balance between the Earth and the Sun. It's where the Sun tugs on it, and then but the Earth tugs on it back. So it would normally orbit around Earth a little bit faster than Earth, around the Sun a bit faster than Earth, because it's closer, and the closer it is, the shorter its year. But because of Earth being quite close to it, then that pulls back on it. And so it stays in the balance directly between Earth and the Sun, and then it goes in a kind of what they call a halo orbit. The two tugs of Earth and Sun kind of influence it to go around in a circle around the point between Earth and the Sun, and then it would gradually drift out in a kind of spiral, and it would head off in a kind of like a helix, more kind of spiral, a bit like synchrotron, so it spirals away towards the Sun. Or it could spiral away towards Earth, and then away past Earth, and then away out in the other direction. So it's got in halo orbit, but it can spiral off towards the Sun, from not actually towards the Sun, but around, and then into a separate orbit around the Sun, and away from Earth's influence if it's left for too long, if it's left to itself. So it needs it needs engines to keep it in place in between Earth and the Sun. It's an unstable equilibrium, mathematically defined. And so this is going to be sitting there, and because it's in space, it's not affected by twilight. So the reason that they found they used this dark energy telescope, which is often optimized in red light. It's very sensitive to red light, and it was, so that's very useful for looking for asteroids. And I looked at this in the twilight, astronomical twilight, when it would be pretty dark to human eyes, but to astronomers it counts as twilight. And so it reduced the sensitivity of their searches. And so astronomical twilight extends a little bit longer than what most of us think of as twilight. So it would be kind of quite dark, but a bit of light in the sky. And so this was searching for it in astronomical twilight, and that's how he found it. And previous telescopes had searched for these asteroids and missed them of about a meter diameter telescope, and this was a 4 meters diameter telescope, which is like 13 feet, which is like the size of a house, and like depending on the size of your house, like the size of a house, certainly a one-story house with a steep roof, something like that. Then that's about the size of the mirror of this telescope, and then the telescope itself is typically a size multi-story building, with this as its mirror, and then it had a huge camera attached to it, and this camera, is it's optimized to red, and this is what they used to discover it. So quite a difficult thing, to spot. And so that's why it was hidden for so discovered. Why it was quite difficult to spot. And so, as I said, it's not a tiny kill; it's 1,000th of the mass of the dinosaur asteroid, because it's about a tenth of the size, very roughly. If it was a kilometre, it would be a tenth of the diameter, and so because it's a sphere, then that's about 1,000th of the mass. So it's much smaller than the dinosaur asteroid. And of course, I mean, our ancestors survived the dinosaur impact. Warm-blooded creatures had a much better ability to survive it too. And but this is not an extinction type asteroid. Did I talk about this? These are, I just talked about it briefly, so now I'll do it properly. So if this is 1.3 kilometers size and within the range of this asteroid, this was 1950 DA, which is much better known. And so you can simulate your own impact. There's a thing you can click on, and you enter where you want it to go, the coordinates. You can choose a city, or you can go to Google Maps and then get the coordinates and enter them into that form there. And so then if you were to hit on Greenland this size, right in the centre, then this is the area where windows would be shattered. So it would be quite a large area of the whole of Greenland, whole width of it from sea to sea, and about half the island or more. And if something this big was to hit New York, now it's exceedingly unlikely that it would hit an urban area, because only 1/100th of the Earth's surface is urban. But just suppose, thousands of years in the future, but we're going to have the technology to deflect it by then, so you really don't need to worry about this. And we've got the technology already to deflect it, with maybe 20 years or something, and especially if it does flybys of Earth before, because that makes it very sensitive and easy to deflect. Then we could deflect it so it can't hit Earth. Or we could deflect it so it hits the part of Earth we want it to hit, like maybe the middle of Antarctica or the middle of the Greenland ice sheet. Hitting an ice sheet would probably be quite a good idea. For instance, if you can't get it to miss Earth completely, you would get it to hit an ice sheet, say, or you could hit it in the middle of the Pacific or something, whatever you work out is the best place to hit, or the middle of the Sahara Desert or something, by just diverting it a bit. Or if it's going to hit Earth but towards the edge, then you just need to nudge it a little bit to head off into space instead of hitting Earth. So it depends really on its orbit as to what you need to do to deflect it. But so anyway, but we don't need to deflect this because it's not going to hit Earth in the near future, and over thousands of years, who knows? It's probably be quite useful because it's a near Earth object. We probably mined it away to nothing with space mining or something, and made it into space colonies, or who knows what we've done, thousands of years or hundreds of thousands of years. I mean, from now, far more likely to be hundreds of thousands or millions of years from now. But anyway, Suppose something this big was to hit New York, then it would cause glass windows to shatter all the way out to Lake Erie and Lake Ontario. So that gives you an idea of how big it is, and you'd have to evacuate this area of people and anything important there. And so people wouldn't die if you got warning, and you'd know where it's going to hit. You know where it's going to hit to within 100 meters a few days before, but you don't. In order for this sort of size, you don't need that precision, and so you would know weeks before where it's going to hit, and you have loads of time to evacuate that area, and nobody would die, assuming you're tracking it on its way to Earth. And at this size, it'd be extraordinarily unlikely that you could evade all the telescopes we've got looking for it. So, but then we've got NeoCam, and then if it hit the middle of the Atlantic, if it hit the middle of the Pacific, would be easier. Then you get a 10-meter high tsunami, which is quite serious. So you'd have to evacuate all the shores of all the coastlines if that was to happen. So it is a serious asteroid. We don't want it, but it's not a planet killer. That's total hyperbole. It's not even remotely planet killer. It would throw up some dust and ash into the atmosphere. It would throw up some tektites, and once it hit the middle of the Atlantic, well, the Atlantic is very deep. If it hit here, it would throw up tektites, maybe for up to 10,000 kilometers, a few of them. So it would hit up the small bits of rock, 5,000 kilometers or something like that. So there would be, there'd be small bits of asteroids hit the ground, secondary impacts as a result of this, just tiny ones, the size of your hand or something. And so we're talking about something that you wouldn't be aware of. Ideally you'd get protection from it and so on. You'd be indoors, or ideally in the basement if you can find something just on the remote risk of a tektite. That is that sort of thing. But it's not a planet killer, not even remotely. You wouldn't expect any species to go extinct unless it would hit directly on the small habitat of a species at a very limited range. That's about the only way it could make anything go extinct. And the amount of dust it would throw up in the atmosphere would be a bit like Pinatubo maybe, or something like that. Like not a super volcano, but quite a large ordinary volcano impact. Cool it down slightly. That happened in the late 20th century, and hardly anyone except geeks even noticed there was any effect on climate, which was warming anyway, and it cooled it slightly. So that's about that. That's like the Homo erectus. These are what human beings were like the last time an asteroid this big was to hit Earth. Long before present-day humans, long before Neanderthals, long before Homo sapiens, Homo erectus, or a little bit of a type of an Eve, or no. And that's the distance that between one end to the other of the strewn field, where the tektites are from New Zealand to Vietnam. I did. And that's the distance of the strewn field, very approximately, rather uneven shape, where they found these tektites. And these are the hand axes that they found of the pre-humans amongst the tektites. And that's just a mistake, as I said. So it's expected the 1950 DA, the only one in the risk list, plenty of time deflected, expected to miss in 2880. Indeed, over 7 centuries could easily mine 1950 DA away as well, very, very likely, or do something with it, because they're very useful, the asteroids, in near Earth orbit, or they would be, for instance, material to use to protect settlements, and they might have valuable elements in them and things. Once we get to the technology where it's easy to do asteroid mining. Now, the CNN clickbait video, it talked about this 2019 asteroid we spotted only after the flyby. This was far, far smaller. It was 500 meters. It would have a similar impact to a small hurricane. It only went slightly above the normal alert level. It never reached anywhere close to needing public warning. And so there's this story about it. And so when it was first assessed with potential risk, it was a very broad assessed hazard zone. So you work out the hazard zone for next time it flies past Earth, and when you first get it, you just see a point of light. You don't know where it's going, so you've got to take another photograph before you've got an orbit at all. And then you get a very broad orbit because you've just got 2 points, and the 2 points are very close together. I can imagine there to there, and you're a little bit uncertainty. Let's see, get both my fingers here. So if you've got that much uncertainty, and then you imagine trying to continue an orbit, sit there or sit there, you're going to have a huge, huge range of orbits. And then once you get them further apart, then you have a much better idea of where it is, just based on the uncertainty of the measurement. You can't measure each point exactly. And then, so the assessed zone gets narrower and narrower as they get more observations. But it could easily be that just by chance Earth is within a narrow band of this object, and that happens quite often. And so then, as if it's within that narrow band of it, but it's nowhere near it, in this case 7 million kilometers away, that's quite narrow compared with the very broad thing. So maybe to start with, it was like they were looking at a band that would be of width of, that 7 million would be the Earth's. It would be more than that. I don't know what their band was. It would be more than that, how far away it was, because it would have an Earth fly by. Say it was 10 million kilometers away, and then say the first, just for instance, I don't know the exact numbers, and then suppose the first one was 100,000 kilometers wide, and they gradually narrow, and then it's 50 kilometers wide, 50,000 kilometers wide, then the risk would seem to go up, because Earth is still within it, and it's a much narrower range. And then we get down to, say, 20,000 kilometers wide, and Earth would be just within it if it was 10,000 kilometers away. And then they go down to 5,000 kilometers wide, and suddenly Earth is removed. So that's why, and people look at that and they sometimes think, oh, that's suspicious. It was increasing in risk, and then they just suddenly removed it. Why did the astronomers suddenly remove this asteroid, which seemed to be a risk? So you get these conspiracy theory ideas. Well, they must be hiding it. It's not because they're hiding it, it's because the hazard zone gets smaller and smaller, and then suddenly, and that's how you expect it to happen, suddenly it gets so small that the Earth is outside it, and then it's removed. So that's very normal for the risk to go up slightly and then be removed. This just went to above normal. This one in 2019, it never got to the level of being a public warning at all, not even remotely close. And every year, 1 or 2 asteroids move to the one level, green. No, sorry, not even above normal. So you have no hazard, and then you have normal. So this rose from no hazard to normal, and then it fell back to no hazard, and then it was removed. And that's quite a common sequence. That they originally find it it's no hazard. As they narrow the hazard corridor, then it goes up to normal, and then as they narrow it even further, it's removed. So that's what happened with asteroid 2022 AE1. That was never any threat to Earth. And if we do spot an asteroid, even hundreds of kilometers, we can move it. We can easily evacuate as for a hurricane. Think of it as a hurricane that you know about, but you can predict it at least 6 days before impact. You can predict it within 100 meters. This was an example. This is an exercise, not a real asteroid, and they had it 100 kilometer radius region to evacuate, and so that's not too different from a hurricane. And then they had a prediction. This is an exercise, not a real asteroid. They invented a fictional asteroid, and then they went through the entire exercise. They do that every year or two, and a couple of years, I think. And they had it exact to 100 meters, 6 days before impact. So nobody's going to die of any of these asteroids in that very remote chance. But this again is tens of thousands of years. And this is the area you absolutely have to survive. This area you could possibly stay if you, like in a basement or something. But you really, they would actually evacuate from that entire area, and probably even for that, that's the serious area. So they evacuate from that. And so so there's no real this is extraordinarily unlikely to be a vastly improbable scenario. Not totally impossible, but vastly improbable. And the expected wait time is many thousands, tens of thousands of years before an asteroid that big. And that's the 100 meters. And this one was 500 meters, and it's exceptionally unlikely that anything of that size is headed our way anytime soon, in less than tens, hundreds of thousands of years, probably at that size. And yes, astronomers would tell you about asteroids, and they told the world about this asteroid in February 2022. They told the world about and so that's the thing, they actually told the entire world. It was just there. It was in the risk list, and it was removed. It was in the removed list. If you'd been following the CNEOS, you would see it was removed at that point, and you'd be able to go and check. And they didn't bother to do a news story because it wasn't very newsworthy. And goodness knows why. It's really quite puzzling that there were no stories on January when they discovered this. So that was on the risk list. It went all the way up to normal. It was a 1.5 kilometer asteroid, and at that time, if they had run a story, then they would have been able to run a story saying that the astronomers didn't know for sure it was going to miss Earth, but they didn't run any story. And then on the 2nd of February, it was removed. I would have known, because there would be people in our Doomsday Debunk group that would have been asking for help. That was just before the Ukraine war, and there wasn't any big asteroid story just before the Ukraine war. So no, they didn't run any story about it back then. And now they're running the story, and they're claiming it's a killer asteroid, and they're getting people scared. And then you've got to look very closely to realise they said generations ahead, but they say it in a vague way, and they didn't exactly say that it's been removed from the risk list in the CNN story, which is the one that scared people most of all. They were a bit clearer in the New York Times story, but only if you read into the details of the story. You had to go down, you read it line by line, and eventually you'd find this line saying that they couldn't hit us this century. But the whole thing was all about it being scary and calling it a killer asteroid. And then if you look very carefully and read carefully, and you've got to remember, and these people who write these news stories, they don't realise that people come to them who are already keyed up to be scared of asteroids, and they've got a panicking state of mind. And when you are panicking, you don't think clearly. You read the clickbait headline, you panic, you might be suicidal. You come to a group like ours and you say, this asteroid is going to hit Earth, what can we do? Or, is it going to hit Earth? The people in the Doomsday Debunk group are somewhat educated about asteroids, and they have come to realise that there are lots and lots of fake stories. Lots of people out there who've never had this debunked, and they've lived through many asteroids that they think were going to hit Earth, and nobody ever told them it wouldn't. So you've got to remember that they've been and I get contacted by people who were, for instance, students, and they stopped, and they had to leave, they had to stop being a student because they're so paralysed with fear about asteroids and scared to leave their house. And they just gradually do baby steps, gradually learn that they're not going to be hit by an asteroid if they step out the front door of their house. They know they're not safe from an asteroid in their house, but they feel safer there, and they'd rather die in their house than out of doors. So they just stay indoors, and they can spend weeks or longer indoors because they're scared of asteroids. They were doing some course of some subject they loved at university, and then usually not a science subject, and then they heard this, or there's some other cases and so journalists, they just no idea of the level of panic and the level of fear that certain vulnerable people get triggered to as a result of this. And so this is why I write my debunks, this is why I say my videos. It's to help these people It's nothing to do with the astronomers. I'm not saying that they're wrong to talk in hyperbolic ways, because they're obviously keen on their subject. They're trying to get people to do more investing in looking for asteroids. They want to, and so they tend to exaggerate a little bit. That's a natural human tendency, and they also don't understand the impact of these exaggerations on the very vulnerable people that come to get help in places like Doomsday Debunked. They tend to be people who are either one, very imaginative or very empathic, or two, they are autistic, or three, they have bipolar disorder, and especially in their manic phase, they're extremely sensitive, and in the depressive phase, they're suicidal. And so, if you're manic, or if you're bipolar, if you're autistic, or if you're imaginative, and this is just anecdotal, then you are extremely at risk. And then if you're a mixture of the two, so we get people who are imaginative, autistic, and bipolar, and the people of all three of those, they're exceptionally vulnerable to being scared by this. There are people who are autistic and very imaginative, and autistic because I think it, so I'm just anecdotal. Imaginative empathic means you get a very vivid, you empathic means you experience other people's emotions, and you're very vulnerable to emotions. If you are imaginative, then you imagine very, very vivid scenarios, and you have very vivid nightmares. If you are autistic, your mind tends to get stuck in a line, and you get interested in railways, for instance, and you don't lose any interest. So their mind is able to settle on any topic and then just sit there. So they get scared by asteroids, they go and search line asteroids, they have a single track mind, they're only thinking about asteroids. So autistic people, they tend to find it very easy to focus for hours on end, and that's a big asset in some areas, but if it's something you're scared of, and your mind just settles on that, and there's nothing distracts you from it, then you're very vulnerable to getting scared. And then there's the bipolar, where they get their judgment extremely impaired when they're in manic phase, where anything that passes through their mind, they're totally convinced by it, and they think it's blinding revelation, and so they're very easily convinced that something scary is true. And then in the depressive phase, they get suicidal. So this is just anecdotal. I haven't studied this, but if somebody was to study it, I think they would find that those three groups are especially vulnerable to being scared extremely and panicking. And you're talking about just words, nothing physically happened to them, and then diagnosed with PTSD, for instance, post-traumatic stress disorder, just from reading something. And psychologists, psychiatrists, therapists, they find it very difficult to believe at first that that is what caused the trauma that they're seeing. They was just reading something, but it is indeed true. And so we get really very extreme anxiety disorders. We don't help them. We don't do the therapy. We just do the fact-checking, but many of them are seeing therapists. And often the only thing that caused the anxiety was clickbait stories. That's the sort you talk to them, and they say, well, until I saw the story about this mythical planet or about asteroids, I just leading a normal, happy life. And then, since then, I've been extremely anxious and panicking. And so, please, if any of you watching this have any connection with the mass media or with astronomers who make these announcements, to try to help spread awareness to how much of an impact it has on a particular small but not tiny, significant percentage group of people in the population that are extremely impacted by stories like this. And basically I've dedicated my retirement years to helping these scared people as voluntary fact checker. And so we know all the ones in the risk. We know all the very large ones, the dinosaur killer asteroids and non-collidators for thousands of years, and this we and yes, astronauts tell us about them. And now the most likely next asteroid warning is a harmless splosh in the ocean. So that's because it's likely to be a very small asteroid, and it would fire up a splash hundreds of meters high, and you can see the size of a plane compared to it, and but just be astronomers going out and looking at it, really quite dramatic. So don't, we might be hit by a small asteroid sometime this century or next, but quite likely, because we were hit by the Chelyabinsk one, and that wasn't big enough to cause something like this, but a little bit bigger. They're hit more likely several centuries apart, so it's not too likely we get hit by something this big, but we might do this century, and but it's very unlikely. It's like if it hit land, then it's like a tiny hurricane, a small hurricane, that we know exactly and can easily evacuate. If it's in the ocean, then it's just going to be a big splosh. It's not going to cause a tsunami. It's not big enough. Right. Yes, I'll talk to you about this separately. This is I've done a non-techie interface to the NASA Search for Near Objects Studies asteroid list. I think I've done everything. So hopefully this helps you to be less scared of asteroids and less scared of this particular thing. And to do it, so you can go search my list if you need to be assured. Just sadly it's clickbait, and do remember these people. They don't know what they're doing. So they're not trying to harm you in any way. They're just doing this because they've been trained to do it. They're journalists, and they try to make it relevant and interesting and clickbaity, and you can tell by the way they talk they're not scared. I mean, just try. If you are empathic, you may be quite good at picking up whether someone is scared or not, and you just try using your empathy and thinking, is this person scared? And you find, it's pretty clear they're not. They find it quite funny even and enjoyable. So they don't really taking it seriously, and so that gives you some idea that they're not really believing this planet killer. I think she probably picked up that planet killer was hyperbole, and because she wasn't acting scared, and she was saying it's a long time in the future and it's thousands of years and so on. So just remember, the journalists they do exaggerate, they do clickbait, they do, they probably wouldn't think of it as clickbait. They would think we're trying to make it fun and interesting and relevant to our audience. That might be more how they're thinking about it. So we just heighten it up a little bit to make it a little bit more vivid. So they're going to click and listen, and they're going to kind of brighten their day a bit, sort of thing. They're not trying to scare people, I don't think. But this is absolutely no risk at all. It was removed 8 months ago or something, and astronomers were never really concerned about it. It only just went from no hazard to normal. That's as high as it went, and it was removed. And this happened so many times that 857 of them, I don't know how many were removed from the risk list at 1 kilometre high, at 1 kilometre diameter. But yes, so it was 857, sorry, it wasn't 856 removed, because a lot of them are never even added to it. They're just near Earth objects, but they're not. They weren't at any point seen to be headed towards Earth this century, so they never entered it. So I think I said at the beginning the 856 removed. There were quite a few removed, but not hundreds of them, because most of those 856 never even had a risk of coming close to Earth. So we found 857 asteroids. Only one of them remains in the risk list. Several, I can't remember. I'm not sure how many, but quite a few have been in the risk list and then they've been removed, like happened with this one. And maybe 3, 4, 5 or something like that. I'm not sure, and there might be more than that. And we found almost all of them, and there probably are a few at this size that are left. In this steeply inclined orbit, it's even less likely that they would even be going to hit centuries in the future. So most likely it's just going to be the same as this one. And we have got a telescope coming in 2023, which is going to find most of the ones that are left. And then we've got a space telescope in 2025, which is going to find most of the ones that the Vera Rubin telescope didn't discover in 2023. And the Vera Rubin is going to keep on looking for them all the way through to 2030. And we've got loads of telescopes out every day, and as soon as they shift far enough from the sun in the sky to be out of the twilight sky, they're all going to be spotted. And if they're anywhere near Earth at all, all those telescopes are going to spot them pretty much within a few days of each other. Just depending how long it takes for them to cycle around the entire sky. So by the time whenever they get to it, they're going to spot it. Because at this size, you can spot them a long, long distance away. So the main problem is them being close to the sun, or else being very far away, close to Jupiter. And even out to the outer edge of the asteroid belt, we can spot some quite large asteroids right now. I'm not quite sure the sensitivity yet. I've looked that up. But our telescope's amazingly sensitive. So the risk, we would almost certainly, if there is one headed our way, then it's, I think, I don't know if I can say totally, I think I can say just about certain that we would spot something this size at least a year in advance anyway. It would be really quite hard, because if it's been hidden for so long, then it's very likely quite synchronized with Earth's orbit, and so it just would take a long time to drift past, or else it's in a very big, long, looping orbit like this one, and it's not likely that it's going to be hitting. And they do these simulations. So they did a simulation for the Atlas telescope, and they did a simulation for, was the Atlas telescope, and this telescope that was launched, that was started 10 years ago, and I think it was a decade ago anyway, and they said that they would spot a 1 kilometre asteroid with near certainty 1 year before it could get near to Earth. With that particular paper I remember reading. And so so it's extremely unlikely though that we're even going to find anything like this that is going to hit in expected wait time at this size is hundreds of thousands of years. Anyway, we've discovered nearly all of them, and then it's almost certainly there's just a handful left. Not likely to be as many as a few dozen left now. They think it's pretty much complete now. Date 57. So like a few years back, they said there might be a few dozen left, and they've discovered several more since then. They've got much better telescopes, and they now say it's pretty much complete, but they're not giving any numbers anymore as to how many. I can't find any recent surveys saying how many they think is left. So I think they're just not very sure how many are left, but we're not talking about many dozens left. We're talking more about a handful, maybe. But I don't think they'd be willing to say. So there could be a few left to find at this size, but it's not something to be worried about. So I hope that's helped you to be a lot less scared of asteroids now. And if you've got any questions, do say. And this particular one, it was removed 8 months ago.